Alright guys, welcome back. We're in chapter 10 now, dealing with reasoning and proof, but today we're actually starting off with geometric construction, so this is 10.1. Hopefully you've worked through the Pearson module through problem 1, dealing with constructing congruent segments, so now we can deal with the got it. So we are going to start by using a straight edge to draw xy, and one thing that you'll realize if you looked in the lesson is that a straight edge can be a ruler but doesn't have to. It can be anything straight, so it can be the edge of a piece of paper, really just anything straight that you can mark distances on. So I can just draw a quick line, and if I had a straight edge, if I pull one down here, we could measure it if we want to. So this line that I've drawn looks like it's almost 6 centimeters, but then I need to say that that is line RS, so I can say that's R, this is S, and then we need to make a line so this is going to be XY. Let's start there. Then we'll draw RS such that RS is going to be twice of XY. So if you had a straight edge, you start at one edge, mark your beginning point, start at the next edge, mark that point, and then move your straight edge so that you can extend the segment to be double its original length. Since I have the advantage of a computer, I can essentially just clone that object and extend out the other direction end to end. So now XY is right here, but RS is the long length of the entire section. Now here we are on the second got it. Hopefully you have looked at problem 2 on Pearson to understand how we construct congruent angles. It is not just lay a piece of paper over top of it and draw the same thing or measure it with a protractor. We are assuming that the only thing we really have to work with is a straight edge and a compass. It's the old method that Pythagoras actually took. So if we want to construct angle F, so that angle F measures 2 of angle B, we have a nice method where we can use to actually construct an angle that's congruent, and then we can double it. So if we get out our compass, we can mark a point here in our original angle that we're just going to draw a little arc. Now you're going to keep this the same, and most compasses will have a little knob up here that you can tighten it up to make sure that it won't move. So when I bring my compass over to my new angle that I'm forming, so I've just made one side of the angle because it doesn't really matter at this point, and then I can draw that same arc, and what I know is that this point here is the same distance away from the vertex as this point up here was distance away from the vertex. So now we make sure that we draw that arc long enough. We come back up to our original, and we are actually going to want to check how wide this is. So assuming that you don't have a ruler, we can then just use the compass to figure out how wide that is. So I need to turn my compass a little bit so I don't actually need to make that drawing. I may run off the page here. So you want to get your compass the same size as that gap. So it may take some turning. So there we go. I am the same size as that gap now. So I bring it down here, and I know that if I went right there, and if I turn this at the correct angle, because I can still rotate even without changing the size. So I'm going to turn so I can get the same angle. A little bit more. So there I'm at the correct angle for the gap. So now if I draw a segment through that point, that will be my congruent angle. So then to double, I can just do the same thing again using this same arc and that same distance again to double. So I'm going to pause the video and do that real quick. So I extended my arc over here so that when I bring my compass back, I can do that again. I've got the distance on my compass, so I can bring it over here. I will get it to show the same distance. So rotate until it works perfectly, and this is when actually doing it by hand is easier. Alright, and once I get that perfectly lined up, I can draw the ray through that new point, which will be my angle that is double the original. So then I can label it so that this is angle F, and I am done. Please make sure that you've worked through the Pearson module for part 3 so that you understand how to make perpendicular bisectors, because I am not going to give every detail. But here we are at the got it. We're told to draw ST. So here is ST, and I can label that. So to draw its perpendicular bisector, again, we are only going to have access to using a compass here. So I set my compass on one end, and the only reason I have a ruler out is because one big thing that's important is making sure that your compass is open to wider than half your line segment. So here my line segment measures 6 centimeters, so my compass needs to be open bigger than the 3 centimeters, so that is good. I'm going to go ahead and change colors so you guys can see this. So let's use green to begin with. So we draw an arced line both above and below. Then I flip my compass around and do the same thing from the other side. And for my application on the computer, I can just as easily just flip it down this direction. So now I've got these 2 arcs. I'm done with my compass now. And what those 2 arcs have done for me is made 2 intersection points, up above and down below. Those intersection points, when I draw my line segment through them, so I start there, go directly through your other one. My segment is slightly off, so we'll shift it to the side there. And that, when it goes perfectly through those 2 points, you know is your perpendicular bisector. So then you can name our point. Let's just say that this point here in the middle is, we can call it W. So now what you know is that SW is equal to WT. So when it's a bisector, it cuts the line in half because it's perpendicular. We know that those are 90-degree angles. Now, if that doesn't make total sense for you, here is the description of how Pearson has you solve it. We can actually go back and verify that it is the bisector. If I take my ruler and check the lengths, it does happen perfectly in the middle between my 2 points at 3. Go ahead and work through the Pearson module for problem 4 and come back for the got it. So here we are on the got it for question 4 on 10-1, and it is asking me to draw an obtuse angle, so I've already got that angle drawn, and then construct its bisector. So in order to do its bisector, we need a compass again. So you can set your compass at any angle you want. Now you don't want it to be too big since this is an obtuse angle already. So I'm going to draw my arc in here, and that then tells me where my other points are. So now that makes Z right here and X right down here, because then I'm going to use my compass again, and I'm actually going to change color so we can see this. And I place my compass at both points. I place it first at Z and draw an arc with that, and then I'm going to place it at X and draw an arc with that. Now the one issue here, you might need to extend your compass so that the arcs will actually cross each other, so that's why I did not make this initial arc that far out. So now I'll use my new arc here off my Z point, and then I'm going to change my color again just to help you be able to see this. And I'm going to place this now on X and draw that arc. And where those arcs cross each other, you know that that point is your perpendicular, or your angle bisector. My apologies there. So I can start at Y, draw my line straight through that point, and I have my angle bisector. So then we could name the point out here, say something maybe W again, and we can say ZYW will be equal to WYX. And another way to talk about equal shapes or equal sizes is to say that they are congruent. That is all I really have for 10-1, so please make sure that this all makes sense. We are going to dive right into reasoning and proof with our next lessons, so please let me know if you have any questions or concerns. Other than that, work through your homework and come back for 10-2. Have a great day.